So to multiply polynomials, there are three ways or three types of polynomial multiplication. We break it up. The thing that you have to be acutely aware of is any multiplication. To multiply polynomials, you use the properties of exponents. To multiply polynomials, you use the properties of exponents. So, in a way, the first example that we're going to do, the first type of multiplying polynomials, you've already done. It was a pre-algebra concept. So the first way, let's call it number one. Example number one, right? Problem set number one is a monomial times a monomial. What do you know? What is a monomial? One term, right? So one thing times one thing. One term times one term. So, for example, 5x squared times 4x to the third. A monomial, 5x squared, times another monomial, 4x to the third. Now, the problem is this is a multiplication. So your brain, we just did addition and subtraction. Your brain tells you they don't go together because when adding and subtracting, they have different exponents. But this is not adding and subtracting. We don't care about like terms as much. In this problem, what do? We've done these for bell work. What's the first thing you do? Julie? Okay, you're going to add the exponents. And I'm going to put in parentheses of like variables. V-A-R-I. Variables. So if there are x's, those x exponents get added together. If there are y's, those y exponents get added together. Can you add the exponents of x to the exponents of y?
Yes.
No. It's only of like variables. What else do you do in this type of problem? We got our exponents, we got our variables taken care of. What else do we do? Multiply the coefficients. And multiply the coefficients has no special rule to it. No matter what, you always multiply the coefficients and you always add the exponents, but you can only add the exponents of like variables. Not like terms, like variables. So, let's do some examples. So let's do the first example, the one that's written down there already. 5x squared times 4x to the third. 5x squared times 4x to the third. Let's multiply our coefficients first, just because they come first. 5 times 4 is 20. And add our exponents, because they're both x's. They're the same variable. They're not like terms, but they're the same variable. So 2 plus 3 is
5. 7. Dylan, you're amazing.
So our answer is 20x to the 5th. I know, there's a delay. Let's do another one. Negative 8x y to the 3rd times 2x squared y times 10xy z to the 4th. So again, they're all monomials, correct? The first one's a monomial, the second one's a monomial, and the third one's a monomial. Monomial times monomial times monomial, right? It's monomials. We're going to have one answer. There are no addition signs, no minus signs in our problem. There can be a negative, but we're not affecting the answer by adding or subtracting. So again, let's do coefficients first and then exponents. So I have negative 8 times 2 times 10. Negative 8 times 2 times 10. Negative 160. Negative 8 times 2 times 10. I'm multiplying the monomials. Now I'm going to go in and add the exponents, but I'm only adding the exponents of like variables. So my first is x, and what's the exponent with the variable x?
1.
There's a 1 right here. What else goes with that x to the first power? There's an x to the second power. Anything else?
Just the regular x.
There's another x to the first power. So x to the what?
4th power.
X to the 4th. Then we move on to y. So I have y to the 3rd power. I have, what else?
Y to the 1st power.
Y to the 1st power. And I have y to the 1st power again. So what do I get?
Y to the 5th power.
Y to the 5th power. And then I'm left over with a z to the 4th. Where does it go?
At the end.
Just at the end. So the answer is negative 160 x to the 4th, y to the 5th, z to the 4th. So that's a monomial times a monomial. So maybe let's put a hint down here. Fill in the hidden ones. That's going to help, especially in the beginning. Fill in the hidden ones. So those hidden ones can be exponents or coefficients. Those hidden ones can be exponents or they can be written as coefficients. So this right here, this is pre-algebra. This is stuff that you already did at one point in time. These are properties of exponents. Multiply the coefficients, add the exponents. So we'll take it a little step further because, I mean, we're going to get to problems that are way more complex than this. But one step down the rung, right, a little bit harder, would be a monomial times a polynomial. A monomial times a polynomial. So for example, 3x squared y times 10x minus 4y. Right? I have a monomial as my first, 3x squared y, and it's multiplied this time by a binomial, but it's a poly, it has more than one, right? So this one's a little bit different. Now here's my question. What if this monomial up front, what if instead of 3x squared y, what if it just said 3? What would you do? You distribute. You're going to do the same thing for this. So you distribute the monomial to each term of the polynomial. Distribute the monomial to each term of the polynomial. And then you use the same rules, right? You multiply the coefficients. And you add the exponents of like variables. So it just has one extra addition onto it, right? You take the monomial times the first term, get an answer, and then you take the monomial times the second term and get an answer. And if there's a third term, you take the monomial times the third term and get an answer. Zach?
What do you do if there's like, what if your monomial was like 3y and then your polynomial was like 10x minus 7x squared, so that there's no y?
It just gets tacked onto the end of that one with no y.
Okay.
For example, I mean, right, if you look at 3x squared y, it's getting multiplied by 10x. Your x's can be combined, but there's no y for it to get added to, so it just gets tacked onto the end. So let's practice. 3x squared y, 10x minus 4y. So that's red, 3x squared y times the quantity 10x minus 4y. So we're distributing, so that outside monomial gets distributed to the 10x, and it gets distributed to the, what's the second term? What's the second term of that binomial? Negative, right? The negative belongs with the 4. Why? Okay, so term number 1. I'm going to rewrite it. You do not have to do this on your homework. But to show it, I'm going to rewrite, we're doing 4x squared y times 10x. So that you can see in your notes, this is what I did. 4x squared, or 3x squared y, sorry, times 10x. So multiply the coefficients. 3 times 10 is 30. X squared times x to the first is x to the third. And what do I do with this y? There's nobody for it to become friends with. Just goes on to the end. But I'm not done because that was just the first term. I now need to multiply it to the second term. So my next problem is 3x squared y times negative 4y. Because I multiplied it by the first term of that binomial. Now I'm distributing it to the second term of the binomial. And again, multiply the coefficients first. So 3 times negative 4 is, if it was a positive number, you'd put a plus 12, right? But it's a negative, so we put negative 12 or minus 12. X squared, is there an x for that x squared to join with?
No.
So I just put x squared. And then y to the first times y to the first makes what? Y to the second, or y squared. And that's your answer.
Wait, what? So it's a binomial?
It's a binomial. Your answer turns into a binomial. Most of the time, not all the time, but pretty regularly, your answer will be the size of the greatest polynomial. So in this problem, we have a monomial times a binomial. If you're distributing, binomial is the biggest, so your answer will most likely be a binomial. You can't combine them because they're different. The exponents are different. They're not like terms. You should end up, if you have a problem in the problem, your answer should be a problem. If there's an addition or subtraction sign in the original problem, your answer should have an addition or subtraction sign in it. Zach.
Will your, what if your answer are both the same term? Like they end up being both the same term? Somehow then?
Most likely. On your homework, it will not happen.
Okay.
If it happens, you should have simplified beforehand so it would have looked different.
What are you doing?
Giving you another problem.
That's not cool.
All right, this problem, we have a monomial times a binomial, correct?
Yeah.
Left to right. Do the problem left to right. So if this, shows up, left to right. So the first thing we do is multiply the monomials. 3x times 4x to the third. What do you get?
12x to the fourth.
3 times 4 is 12. X to the first times x to the third is
X to the fourth.
x to the fourth. Then I can distribute. I can distribute 12x to the fourth to 2x minus 10y.
That's not the color I'm on, though. I'm on the
Gets distributed inside, right? What's 12 times 2? 24. What's x to the fourth times x to the first?
X to the fifth.
X to the fifth. Then I'm going to distribute to the second term 12x to the fourth times negative 10y. Multiply your coefficients first. What's 12 times negative 10? Can you combine your variables? So what's your answer going to be? X to the fourth, y to the fourth, because they're different variables.